Welcome, class. Settle in because today in this explainer, we're doing a little time traveling. We are heading way back to ancient India to look inside the astonishing mind of a true scientific revolutionary, Aryabhata. I want you to imagine peering up at the night sky over 1,500 years ago. You have no telescope, no computer, no modern gadgets of any kind. And yet somehow you manage to unlock the deepest mechanical secrets of the universe. Well, that is exactly what we're going to explore today. Okay, let's dive right in. Aryabhata was this absolutely legendary mathematician and astronomer who thrived during the Gupta period, right around 499 CE. And his calculations were so monumentally advanced, so far ahead of their time, that India actually named its very first modern space satellite after him. Think about that for a second. The ancient planetary findings of this one individual directly connect to the satellite technology orbiting our planet today. It's just mind-blowing.
So, to truly wrap our heads around his genius, we'll be exploring his life and work through 5 key sections: the cosmic pioneer, unlocking the solar system, mastering cosmic time, the mathematical innovator, and finally, an enduring global legacy. Let's get started.
Section 1. The Cosmic Pioneer.
Now, Aryabhata wrote his most highly influential text, a masterpiece called the Aryabhatiya, when he was just 23 years old. 23! He organized this massive body of complex ideas into a simple, structured format spanning 4 main chapters. He covered everything from planetary cosmology in the Gatikapada to mathematics and quadratic equations in the Ganatapada. Then he tackled the measurement of time in the Kalakriyapada, and finally, the true shape of the Earth and celestial equations in the Golapada.
Moving right along to Section 2, unlocking the solar system.
So, how exactly did he figure out the mechanics of our solar system without modern tools? Time for our first classroom mental activity. I want you to imagine you're standing on a moving boat looking out at a completely stationary object on the shore. As your boat moves forward, the shore appears to be moving backward, right? Well, Aryabhata used this brilliant, incredibly simple analogy to explain why the seemingly motionless stars in the night sky consistently appear to move westward. He realized it wasn't the sky rotating around us, which is what literally everyone else believed. It was the Earth. The Earth is rotating on its own axis.
And this realization was a total game changer. It allowed him to completely challenge the prevailing myths of his time. See, lots of ancient cultures fully believed that eclipses were caused by shadow demons swallowing the sun. But Aryabhata proved that, nope, they're simply caused by the true, physical shadows of the Earth and the Moon. On top of that, he correctly figured out that moons and planets don't emit their own light. They actually shine by reflecting sunlight.
That brings us to Section 3, Mastering Cosmic Time.
The crucial point here is that his raw data was practically indistinguishable from modern science. Take a look at this. Aryabhata estimated the Earth's circumference to be 39,968 kilometers. Today, our modern satellite measurements put it at 40,075 kilometers. You guys, that is an error rate of just 0.2%. And he accomplished this over 1,500 years ago.
But wait, it gets even better. Listen to this jaw-dropping number. His exact calculation for the Earth's sidereal rotation, which is the time it takes the Earth to rotate exactly once relative to the stars, was 23 hours, 56 minutes, and 4.1 seconds. Today, our hyper-precise digital clocks measure it at 4.091 seconds. He was off by a microscopic 0.09 seconds. He also calculated the length of a sidereal year to be 365.25858 days, which is just spot on with our modern understanding.
You're probably wondering, how on earth did he do it? Well, not with giant lenses or lasers for sure. It was all pure human ingenuity. Working at his observatory at the Sun Temple in Telangana, he used incredibly creative but super simple tools. We're talking shadow instruments like the gnomon, basic angle measuring devices, and cylindrical water clocks to meticulously track time and celestial movements.
In fact, we can actually turn this into an outdoor classroom experiment that you can try yourself. We can basically replicate Aryabhata's method using his Yashti Yantra, which is essentially just a cylindrical stick. Step 1. You set your stick perfectly vertical on flat ground in the schoolyard. Step 2. Track the changing angle and length of the sun's shadow throughout the day. Step 3. Measure the time intervals using a simple water clock. It proves that with just a stick, a shadow, and a consistent measure of time, you can map the basic geometry of our entire solar system.
Let's pivot from the cosmos back down to Earth for Section 4, the mathematical innovator.
All right, class, grab your calculators. Let's follow his exact formula from the Aryabhatiyam for calculating the circumference of a circle.
Ready? Step 1, add 4 to 100. That gives us 104. Step 2, multiply by 8, giving us 832. Step 3, add 62,000, which equals 62,832. Step 4, divide that whole thing by 20,000, and the result? 3.1416. That is an incredibly accurate calculation of pi down to 4 decimal places. And what's even crazier is that he correctly identified that this value is an irrational number. He formulated that centuries before it was officially proven over in Europe in 1761.
And this naturally leads us to one of the most foundational concepts in literally all of mathematics. Now, while he didn't explicitly draw a circle to represent the number 0 like we do today, Aryabhata developed this brilliant alphabetical counting system. To make it work, he utilized the concept of 0 as a crucial placeholder for powers of 10 with null coefficients. It was a groundbreaking early understanding of 0 that made super complex calculations, like finding square and cubic roots, actually possible.
He also completely transformed geometry. By using really easy-to-follow geometric visuals, he stated that the area of a triangle is the result of a perpendicular multiplied by the half side. He made complex math incredibly accessible. He created detailed tables of signs and even introduced the concept of the versene to trigonometric calculations. Honestly, these are the exact same mathematical principles we use in our hands-on shadow trigonometry activities today.
Finally, Section 5, an enduring global legacy.
So how did this ancient genius shape the rest of the scientific world? Well, knowledge this powerful just couldn't be contained. After 499 CE, his mathematical methods spread like wildfire across the globe. During the Islamic Golden Age, his incredible trigonometric tables fundamentally influenced Islamic astronomy, directly inspiring the creation of Arabic astronomical tables known as zijas. By the 1200s, his work surged into Europe when it was translated into Latin. And of course, the journey comes full circle in the modern era, with India honoring his immense contributions by naming their very first satellite after him.
All right, before we wrap up today's lesson, it's pop quiz time. Let's check our understanding of his core discoveries. Which simple analogy did Aryabhata use to successfully prove that the Earth rotates on its axis? Think back to that mental exercise we did earlier. Got it? Yep, it's the boat analogy. By comparing our viewpoint on Earth to a passenger moving forward on a boat and watching the stationary shoreline recede, he beautifully proved the Earth's axial rotation.
Aryabhata was just an absolute towering figure in history. He proved that you don't necessarily need the most advanced, high-tech gadgets to understand the universe. He mapped the cosmos with simple sticks, shadows, and the raw power of his intellect. So, I want to leave you with this final thought for today's explainer. If he could map the solar system with sticks and shadows, what hidden cosmic secrets will you uncover with the tools you have today? Thanks for joining class today, guys, and keep looking up.